Everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Foundation Tier from 2007, 2025. Question number 7 is on the topic of electricity. A student built a circuit to investigate how the efficiency of a motor varies with the speed of the motor. The symbol of the motor is a circle with an M. Figure 12 shows a circuit. So you have a series circuit with a battery, switch. This is a variable resistor. The motor, ammeter, voltmeter. The student used the motor to lift a mass through a height of 1 meter. The motor took 12 seconds to lift the mass. The charge flow through the circuit was 6 coulombs. Calculate the current. So current I equals the charge flow is 6 divided by the time is 12. 6 divided by 12 is 0.5. So the current is going to be 0.5 amps. 0.50. Potential difference across the motor was 8 volts. The charge was 6. Calculate the energy transferred. So the charge flow is 6 multiplied by the potential difference. 6 multiplied by 8 is 48. 48 joules. Use the physics equation sheet to answer the questions. Which equation links efficiency, total input energy transfer, and useful output energy transfer? Efficiency is equal to the total input. No, not the input. It should be the output divided by the input. The input is always going to be bigger because your efficiency has always got to be smaller than 1. The efficiency of the motor was 0.7. The useful power output energy transfer of the motor was 1.96. Calculate the total input. So 0.70 equals, let's write as input energy divided, no, it's not the input energy, it's how to, right? This is going to be the input, which is, yeah, input energy. Again, I'm making the same mistake. Input energy is at the bottom. So this is going to be the output. So there's no point in writing the equation down. The output energy is 1.96. The input energy is what we are trying to find out. Now I'll know if I made a mistake or not if I get the answer less than 1.96. If I get it as less than 1.96, then it's definitely wrong. So input energy equals 1.96 divided by 0.7. That gives me 2.8, which is correct. The input energy has to be bigger than the output. Yeah, input energy has to be bigger than the output energy. I'm getting it mixed up. 2.8. The student adjusted the speed at which the mass was lifted. For each speed, the student determined the efficiency of the motor. So as you can see, as the speed increases, efficiency is increasing, but not steadily. The rate of efficiency increase is actually slowing down. Use figure 13 to predict the efficiency of the motor when the speed was 0.6. So I will have to draw a line which should actually follow this. So I do that. At 0 point, it will be 0.75. So the marking scheme says any answer between 0.74 and 0.78 will be fine. How does figure 13 show that the efficiency of the motor is not directly proportional to the speed? The line is curved. If it was directly proportional, it would be a straight line going through the origin, right? And here, the line doesn't actually go through the origin. Because if you did extend it, it's actually going to fall before 0. That brings us to the end of this question. Now, question number 8 is actually onwards. Question 8, 9, and 10 are higher tier questions. So I will be attaching those 3 videos from the higher tier paper into the end of this playlist for you to watch. Thanks for watching. Hopefully you find this useful. And thanks for subscribing if you did. If not, maybe it'll be useful. Consider that. Thank you.